Hello, in this video I'm going to be showing you a stack and queue implementation using JavaScript. So first, to refresh your memory on what a stack is, a stack is characterized by the abbreviation LIFO, standing for last in, first out. Okay, so a stack works in the manner you might expect. You push items onto a stack, and when you want to remove an item, then you take off the top element from the stack. So as we keep pushing elements in to the stack, it's going to get deeper, and removing from the top, kind of like you would in Jenga, ensures that the stack does not just completely fall apart. So that's a stack. A queue is characterized by FIFO, which stands for first in, first out. And this is depicted by a line, similar to lining up for Starbucks. Typically, right, in this case, always, whoever first lines up gets to have their order taken first. So new elements get added to the back of the line, and the line moves forward. So this is a queue. This is the exact definition of a queue. So there are some methods that we should classify for the stack and queue base classes. I'm going to try and keep it simple, but there are two similarities, and that just involves the adding and removing of elements in a stack versus a queue. So a stack, we push elements to a stack, and we remove elements by popping from the stack. A queue, we onqueue to the queue, we enter the queue, and we dequeue. So popping takes out the top level element, so it will take out the last element. Dequeuing will take out the first element. Okay, and let's add some additional methods to peek from the stack and peek from the queue. And what peeking does is just returns to you the value at the last item, the top level item in a stack, and also similarly for the queue, peek will also just return to you the first item, the first item in the queue, without mutating the original object. So the reason why I want to add this peek here is just to show you the mutability of pop and dequeue, because we're going to be using JavaScript. So we're going to, in our implementation, be using .pop, which is a mutation, and dequeue.shift, which also mutates the original array. So with that being said, the implementation is pretty straightforward. Let's call this stacks, and a stack. We don't need we don't need to pass anything to the constructor, but we do need a constructor to store the values. But this dot value or this dot items will be an empty array. Okay, and we're going to have a method called add, and adding will just take in some item. It can be any type because this is JavaScript, and then we're just going to push the items onto the stack. Removing an item in this case will also be similar, but we're going to be using pop instead, and this will just pop off the top element. So we're not actually searching and removing, we're just removing from the top of the stack, because that's the only thing you can do with a stack. You cannot typically search and remove, otherwise you just use an array. So keeping that structure, we have add and we have remove, and I want to implement peek just to show you that if we want to just select the element but not do anything with it, then we're just going to return the first element. Actually this should be the last element. So this dot items dot length -1. So this will return the last element, the last item in the items array. Okay. Without mutating. And similarly for our queue, we're going to be instantiating a items array. We'll be adding an item, and we're just going to this dot items dot on queue the item. And removing, we're going to return this dot items dot dequeue. Now this will either return an item or it will return undefined. That's possible. And peek will return the first item in the array, which may not exist. So let's see, if this dot items dot length, so if there is something, then we want to return this dot items as 0. Otherwise we'll just return undefined. So just use the double ampersand for that. Okay, close that off. Now to test out, let's push some items onto a stack. So const stack equals new stack, stack.add1, stack.add2, stack.add3. Now we're gonna instantiate our queue, new queue, queue.add1, queue.add2, queue.add3. So console.log the stack in queue at this point, and then we're going to dequeue, and then we're going to peek. So stack.dequeue. And then console.log stack. And then we're going to queue stack.remove. We're going to remove, and then we're going to console.log queue. Next, we're going to peek. So queue.peek. And let's return this. So console.log queue.peek. And also stack.peek. And console.log stack and queue, just to show that we did not mutate the original list. We just simply return the value. Okay. So let's run stack. This items.onQueue is not a function. That is because in JavaScript, removing we use shift, and pushing we do still use push. Okay. So we see we added 3 items, and from our stack we removed the last item, and from our queue we remove the first item. Okay. And when we peek, we get the last item in the stack, and then in the queue peek method we get the first item in the queue. And finally, I just console logged the stack in the queue to show that we did not mutate the original stack and the queue. So that is a stack, and that is a queue. These are useful in some DSA questions, like if you want to implement breadth first search, you will use a queue. Okay, you may not necessarily need to create the class definition, but the idea is to add items to the queue and shift the array over if you want to remove, by removing the first item. The stack is useful for operating systems if you want to implement some sort of a tree directory and some priority, then you'd use a stack. Right? Yeah, these are 2 basic algorithms that data structures that occur in some algorithms, so handy to know.